Thank you very much. First of all, I would like to thank the committee for inviting me and giving me this opportunity to speak about my study. Basically, our study, the aim of our study is to try to understand more about obesity and Prader-Willi syndrome. So basically, we try to look at the energy intake and energy output, and we try to kind of find out what is the cause for those imbalance in obesity, imbalance in emergency energy expenditure. I'm sorry. As you all know, we believe Prader-Willi syndrome is a hypothalamic problem, and hypothalamus is the main control center for autonomic nervous system. And there are some evidence of autonomic dysfunction in Prader-Willi syndrome, and we know that the autonomic nervous system has something to do with some control on the ghrelin. So ghrelin is the hormone that we make from the stomach, and ghrelin makes you hungry. And in Prader-Willi syndrome, it's generally believed that ghrelin drives the appetite in Prader-Willi syndrome. And at the same time, we want to look at the energy expenditure in Prader-Willi syndrome, and we want to see if there is any link with the autonomic nervous system and energy expenditure in our data. But we know that energy expenditure is under the control of autonomic nervous system. So the study of the hypothesis on my study is because in Prader-Willi syndrome there is a hypothalamic dysfunction, therefore there is a problem with the autonomic nervous system, therefore there is a poor suppression of ghrelin, therefore there is increased energy intake. And also because the autonomic nervous system has defect, and therefore there is a poor energy expenditure. So that's the aims of the study. So we try to compare the autonomic nervous system or autonomic nervous function in the people affected and people not affected, and also compare the blood acylghrelin level. So acylghrelin is the active form of ghrelin, which makes one hungry. And so we try to compare the fasting acylghrelin level and the acylghrelin level after eating. And then we try to correlate the autonomic finding and the acylghrelin, and we also compare the total energy expenditure and all the subsets of energy expenditure, and try to correlate that with the autonomic finding. So we recruited 16 genetically confirmed Prader-Willi participants and 16 match controls, and we used the cardiovascular testing. We call it orthostatic change in pulse rate, blood pressure, and mean arterial pressure. So once you are lying down and stand up, and then your blood column drops, and then you need to increase the autonomic nervous system to maintain your blood flow to the brain. And we further exaggerate that function by giving a meal. So meal has been shown to have increased stimulation on the sympathetic part of the autonomic nervous system on our cardiovascular tissues. And we also measured the plasma acylghrelin and plasma gastrin and catecholamines and urinary catecholamines to complement the autonomic function. And then we look at the plasma acylghrelin at the fasting level before eating, and then a number of time points after feeding. And we measure the body composition using a BIA method, and we measure the height, weight, body mass index, waist to height ratio. And after the mixed meal study, and then all the participants wore the device called ActiHeart, so which measures the physical activity, heart rate change, and also the linear movement kind of counts, and that device changes that into energy expenditure. So this is what we did At baseline or fasting level, we measure the urinary catecholamines and plasma acylghrelin, gastrin, catecholamines, and then we do the baseline cardiovascular testing. And then we give them a mixed meal, and then we repeated the cardiovascular test and biochemical testing. So moving on to results. The median age of Prader-Willi group was 9.32, and I didn't get controls for a long time, so I wanted to recruit the age-matched control groups, but in the end I had to accept the older controls, so the median age for controls are 12. And Prader-Willi group was shorter, and then they had lean body mass. So this is the change in the pulse rate when you stand up from a lying position. And you can see the baseline is the fasting time point, and then 10 minutes after meal, 60 minutes, 120 minutes after meal. And the red line is the control group who do not have Prader-Willi syndrome. And you can see the pulse rate goes up after eating. And then if you look at the 10-minute point in Prader-Willi group, the pulse rate actually went down. And these are statistically significant in those time points. And similar thing happened in 30 seconds after standing as well. And when you look at the change in the blood pressure, they all didn't make any statistical significance, so I'm going to skip on that. And then went on to mean arterial pressure. So again, the red line is a control group, and the blue line is the Prader-Willi group. And you can see at 120 minutes and 60 minutes, there is a drop in the mean arterial pressure in Prader-Willi group. And then moving on to catecholamines. So catecholamines are the chemicals that gives you flight or fright kind of a reaction. And when compared to the unaffected group, the Prader-Willi group had a pretty similar blood catecholamine levels. And but if you look at the urine catecholamines level, the Prader-Willi group has significantly higher catecholamines level. So we did a number of urine catecholamines, and we universally see higher urinary catecholamines in Prader-Willi syndrome. And moving on to plasma gastrin. So gastrin is a hormone that comes up from the stomach, and then after eating, the Prader-Willi group had a significantly higher, we call it area under curve. So basically, they have a consistently higher plasma gastrin level after meal. But if I break it down into different time points, at 120 minutes, the difference of plasma gastrin level became statistically significant. And in that graph, you can see the Prader-Willi group had a higher plasma gastrin level than the control. So there are a number of studies. They showed that people who had vagotomy, so vagotomy is a surgical operation to cut the vagus nerve for people with peptic ulcer disease. And so if the vagus nerve is taken out, and people found that the plasma gastrin and catecholamine production has increased. So we assume that there is a poor vagal function in Prader-Willi syndrome. That's why the plasma gastrin and plasma and urinary catecholamines are high. So with the cardiovascular changes, we can say that the sympathetic portion of the autonomic nervous system has a defect, and we assume that there might be a poor vagal function in Prader-Willi syndrome as well. And we looked at the plasma acylghrelin, and this is what we found. At fasting level, the plasma acylghrelin level was significantly higher in Prader-Willi group. And there are a number of papers supporting this finding. But interestingly, then the plasma asagrelin dropped very rapidly to the similar level at 60 and 120 minutes after eating, and similar level to the control. So, so we know that asagrelin is driving the hunger, but after meal, it comes down to the similar level. So there must be another mechanism pushing the poor satiation in Prader-Willi syndrome. And rate of fall of plasma asagrelin is significantly faster in Prader-Willi syndrome compared to control. And then my initial aim of correlating the asagrelin and the change in the cardiovascular finding showed that there is a negative association between the fasting asagrelin and the autonomic nervous function. And moving on to energy expenditure, so the device put out the total energy expenditure and resting energy expenditure and activity associated thermogenesis, as well as the non-exercise associated thermogenesis. And we used statistical tools to compare those two groups, because body weight and fat-free mass has effect on the energy expenditure. In other words, if the weight is high, and then the energy expenditure is likely to be high. But to take away that effect, we use a log-log regression method. And as you can see, this is this is a total energy expenditure for 24 hours. And the red dots are controls, and the blue dots are for Prader-Willi syndrome. You can see the energy burning out of energy expenditure per day is significantly lower in Prader-Willi syndrome. And when I try to adjust for the lean body mass or fat-free mass, I still see the difference. And looking at the activity-associated thermogenesis, so this is the energy that you spend during activity. And again, Prader-Willi group has had a lot of significantly lower energy expenditure than the control. Again, adjusting for the fat-free mass, the Prader-Willi group had a low energy burning. And this is what we call a NEAT. So non-exercise associated thermogenesis. And so basically, there is an arbitrary definition of exercise, and to be fair on the persons with Prader-Willi syndrome, we define the period of exercise as high and sustained physical activity and energy expenditure for at least 30 minutes. And then when we take away the energy expenditure during exercise defined by our arbitrary definition, and what's left behind is a non-exercise associated thermogenesis. And in Prader-Willi syndrome, they're significantly lower when adjusted to either weight or the lean body mass. This is resting energy expenditure. And resting energy expenditure is pretty similar, but statistically significant. It's low statistically significant. And I think this is because of the growth hormone therapy in Australia. And again, when adjusted to fat-free mass, the resting energy expenditure in Prader-Willi syndrome group is still low compared to the controls. So from our cardiovascular data, the sympathetic nervous system has a problem, and looking at the biochemical data, and we assume that that situation is very similar to post-vagotomy, so after the vagus nerve's been cut. So all in all, we can say there is a poor autonomic nervous system function in Prader-Willi syndrome. And fasting asagrelin level in Prader-Willi syndrome is high, but the rate of reduction in the acylghrelin is pretty fast. So we make another hypothesis. There must be another factor, that's another mechanism that's stimulating the hunger or blocking the satiation. And we try to make a correlation with fasting acylghrelin, and even though this is not a causal relationship, that there is association between poor autonomic nervous system function and a high acylghrelin level. Again, the energy expenditure, total resting activity associated or non-exercise related, they are lower in Prader-Willi group, and our correlations with the autonomic nervous system and acylghrelin didn't reach any statistical significance. So in Prader-Willi syndrome, at least because of the high fasting acylghrelin level, that's pushing the hunger, and therefore there is an increased energy intake. And there is evidence of low energy expenditure, so there is an imbalance in energy homeostasis in Prader-Willi syndrome, and therefore there is obesity in Prader-Willi syndrome. So I'd like to thank the study participants and their families, and I'd like to thank my supervisors and the funding facilities and then the research team for this job.